Alright, so I'm redoing this video in case some of you already saw it, because the first one, apparently the microphone was set incorrectly. So we'll try it again. But at any rate, I do want to explain how this servo motion module actually works and talk about its code and its arrangement. But before I do that, I actually want to talk about how a servo motor works. Okay, we've played with them before. We played with the little ones that were in the small kit at the beginning of the year. But now we like different servos here. These are bigger, obviously, but they're also modified. These are able to go 360 degrees around, whereas you may recall this guy here only went at most 180 degrees from one position to another. The other thing was kind of cool. These you could set at any one position. Okay, I could say, for example, set it straight at 90 degrees by sending a particular pulse. These guys here, I can't set to a particular position, but I can set to a particular direction and speed. Okay, so we'll get into that here in just a second. But let me show you generally how these things are controlled. They're controlled with a series of pulses, and those pulses have to have a particular sort of pattern to them. So what you need to have is a signal that comes in, and then you have this pulse. Hard to do with one of these days I'm going to buy a drawing pad. Alright, so we got these pulse trains. And these pulses and the dead space are very particular to a servo. Okay, so if we look at it, of course, you should be familiar with this now. This is going to be the high signal, and down here, of course, is going to be the low signal. And these pulses have to be between 1 and 2 milliseconds in duration, or 1,000 and 2,000 microseconds. So all of these are somewhere between that range, and that the length of that is going to tell us, in this particular case, the speed and direction of the motor. In the normal little unmodified stepper, that would have told us where it was, you know, in its arc of movement. But in this case, it's going to tell us our speed and direction. Another real important aspect is the length of dead time, the low time. It has to be 20 milliseconds about. Okay, we need to have these 20 millisecond low periods for the servo to be able to interpret the signal and make sure that the signal is in fact real. And if we look at this, of course, it's actually going along, and this is going to be time right here. Okay, so time is moving along in this direction right here. So the pulses have to be very specific in a train. Okay, just one, we tend to call just one unit like this, we call that a step. Okay, so this is going to be 1 step, 2 step, 3 steps. So when we work with this particular module, we're going to be dealing with steps, how many times it's actually pulsed. Whereas if we were to use the servo motion or the servo library that's included in Arduino, we'd be talking in units of time. How long is the pulse train going to last? Not the total number of pulses within the train. Okay, so that's the biggest difference between this module and the one that's already built into Arduino. Again, the one that's built into Arduino, it's going to be based on the total duration of the pulses, and in this particular case, it's going to be the total number of pulses that occur. So we can, a little bit different, but it gives us a different sense of control. So moving on, I've actually written a couple little pieces of test code that we can kind of see, and I'm actually using a piece of code that I wrote outside of the module. Okay, so this first demonstration, for example, I'm going to show you, it is going to work without using the module at all. It's just raw signal. I'm essentially generating this series of pulse trains using raw code, and you can see it here. So this is a digital write high. Okay, so it sends the signal high. That's the rising edge of that peak. This is going to be the duration of that peak. Okay, so now we're at the high signal, and then we're going to send it low. Boom. Okay, and it goes back down to the low signal, and then it's going to hold it there for 20 milliseconds. And of course, I have it in my loop, so it's just going to be one long series, an infinite series, since I have no way of stopping it in the loop currently, of 2,000 microsecond or 2 millisecond highs followed by 20 millisecond lows. Right? So if I plug my robot in and load it up, and notice I'm actually only pulsing the right servo. Okay, so I'm going to load this up, and what should happen is as soon as it loads, it's going to start flashing this light. I'm going to turn it on, and lo and behold, we're going to see that this guy is moving essentially as fast as it possibly can in a counterclockwise direction. Okay, so if I were to make this a 1,000 and send it over, all right, we're going to see, wait for the light to start to flash, there we go. We're going to see that this motor moves as fast as it possibly can in a clockwise direction. All right, and likewise, just to be demonstrative, if I send in, for example, a 1,500 millisecond pulse, you're going to see that, well, it's going to be really boring, actually. It's not going to move at all, okay? Because 1,500 milliseconds is the midpoint. Slightly more than that, let's make it, say, 1,550. Turn that off for a moment. It's going to move ever so slowly in the counterclockwise position, as it would be moving closer and closer to 2,000. And the closer I get to 2,000, the faster and faster it's going to go. So let me demonstrate that in another way. So I have here a piece of code. And in fact, you can see that I'm going to print it out so we can actually watch it. So let's load this up. And what you're going to see is as this moves, okay, let's see what the code's going to do. It's going to start at 1,000. It's going to go up by 2 all the way up to 2,000, and it's going to go ahead and pulse with that 1 to 2,000 being the amount of time that it remains high. And then once it reaches that 2,000, it's going to come down to this next for loop. It's going to start at 2,000, and it's going to work its way down to 1,000 in increments of 2. And of course, it's going to hold, that'll be the duration of time that it's held high. Please note that these are microseconds, okay? And then the normal delay is in milliseconds. All right, so if I load this up, and we'll get this thing, it's loaded. I'll open up my serial monitor so we can see the data flow. And you can see is that as the value gets closer to 1,500, it stops, slowly going faster and faster until it hits 2,000. Now it's going to start slowing down again. It's going to stop, switch directions, slowly going faster and faster in the clockwise position until it gets 1,000. And of course, the process is going to repeat itself over and over again because it's in an infinite loop. All right. And I should show you, for demonstration purposes, what that looks like with a regular servo. So I have here a high-tech servo. It's a standard servo. It's non-modified. And I'm going to pull the wire here, turn off the power, and plug this guy in. With some difficulty. There we go. And you can see that it goes through the arc of motion. Once it reaches, it slowly works its way back. So we would see this thing going back and forth as it goes between 1,000 and 2,000. So that kind of covers the overall explanation of how a servo works. And I'll pull up yet another video to talk about actually how this module works. So I will see you all again really soon.